Okay, this is a how-to video for how to find a direct rule for an arithmetic sequence. So you can use this video to help you if you are having trouble figuring that out. There's nothing in this video that wasn't done in class, but maybe it's helpful to see it again. This is my first time using this program, so we might run into some glitches. We'll just try to figure it out. So let's say you start off with the sequence 4, 7, 10, 13, 16, 19, 22. Hopefully you've already noticed a pattern going on here. And let's say we want to be able to find other terms of this sequence. Well, we could find a recursive rule, and that would help us. And you don't really need to make a table to find a recursive rule, but let's do it anyway because it's going to be helpful to us later, and also makes it helpful to explain the recursive rule. So if n is 1, 2, 3, 4, 5, that means the first 5 terms of the sequence. The first term, a sub 1, is 4. The second term, a sub 2, is 7. The third term, a sub 3, is 10, etc. And again, hopefully you've already found a pattern, but let's put it in here because it's going to help us later. So in order to get to 7, you increase by 3. So 4 plus 3 is 7, then plus 3 is 10, plus 3 is 13, plus 3 is 16. And the fact that the terms of the sequence are constantly increasing by 3 means that this sequence has a common difference. The difference between the terms is the same. In this case, it's plus 3. So that's what makes this an arithmetic sequence, because it is increasing by the same amount. It could be decreasing by the same amount and be an arithmetic sequence, but in this case, it's not. It's increasing. By how much? By 3. So I'm writing here the recursive rule, and a recursive rule refers to a previous term, so I need to write one term in there to just get us started. So I wrote a sub 1 equals 4, because that was the first term. And a sub n equals a sub n minus 1 plus 3, meaning to find any term, you take the previous term, and add 3. And of course, because it refers to a previous term, that makes this a recursive rule. So, good, we found a rule. We can find any term. What's the problem? Well, of course, the problem is that what if we didn't want to find the next term? What if we wanted to find a term that's far away, such as a sub 100? Well, in order to find a sub 100, you would have to know a sub 99. To find a sub 99, you'd have to know a sub 98, etc., because we only have a recursive rule. In order to get the next term, we have to know the previous term. That seems like a lot of work. So maybe there's a faster, more efficient way of finding a sub 100. And of course there is. We can find a direct rule, which allows us to go directly from knowing the term number, 100, to getting the value of that term, which we don't know yet. So to help us do that, I always like to show my work in the table. We start with 4. And then how did we get 7? We did 4 plus 3. And then how did we get 10? We added 3 again. So 4 plus 3 plus 3. And we keep doing that. So to get 13, we added 4 plus 3 plus 3 plus 3. There are the plus 3s right there. All you have to do is follow it from our starting point, plus 3 to get us 10, and then plus 3 to get us 13. And 4 plus 3 plus 3 plus 3, oh, I lost count, 4 plus 3 plus 3 plus 3 plus 3 to get us 16. Great. So now what? Well, what does that tell us? What do we notice? That's what a common question in math, right? What do we notice? Well, we notice that it seems like we always start with a 4, and then we always add a bunch of 3s. So for this one, if we knew how many times we had to add 3, we could find a sub 100, which is what we're looking for. So the new question is, how many 3s are there right here? All right, we only see 3 of them, but I didn't want to write all of them down. That's why I wrote the dot, 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 right? So there are lots of 3s here. We don't know how many. Up here there were 4, up here there were 3, up here there were 2. So we're noticing that you can go back and try to figure out how to predict how many 3s there will be. So here it's 4 plus 3 plus 3. Well, there are 2 3s. So we can write that as 4 plus 3 times 2, because multiplication is just repeated addition. If you see the same number being added over and over again, a quicker, more efficient way of figuring that out is just multiplying. So 3 plus 3 plus 3 is the same thing as 3 times 3. 3 plus 3 plus 3 plus 3 is the same thing as 3 times 4. Because how many times do we have to add 3? 4 times. 3 times. 2 times. So over here we have to figure out how many times are we going to add 3. And many students would think that's easy. There's 100 3s there. Not 100 3s. There are not 100 3s there. You're making an assumption. Let's see if we notice anything. We'll look right above. All right, this part of the video, I start to lose track of how to make the circles in this particular program, so it's a little messy, but we'll get it here. Ignore that. So let's try to figure out if we can predict, if we know the term number here, how many 3s will there be? And this is going to be common because this is our independent variable. This is what's going to change. And we have to figure out what kind of effect that has. Well, that affects how many 3s there are. So when n is 5, there were 1, 2, 3, 4 3s. So that's why it's 3 times 4. And when n is 4 over here, when n is 4, there are 3 3s, which is why we have 3 times 3. When n was 3, there are 2 3s, so we have 4 plus 3 times 2. So if n is 100, how many 3s will there be? Well, we notice that there's always one less 3 than whatever n is. And of course the reason for that is because we didn't add a 3 the first term. We added 3 to get to the second term. So there's one less than 100 3s, so there are 99 3s. So I didn't want to write all 99 3s here. That's why I did the dot, dot, dot. But there they are. Those are 99 3s there. How do I know? Because n is 100 and the number of 3s is always one less than the term number. So that's great. We can find a sub 100. Could we do that for any n? Of course we could. We could do the same thing we just did if n was 50 or 1,000 or 1,624,000. It doesn't matter. So if we can work for any number, then we just use a variable. That's what a variable is. It's something that represents any number. So n is the letter that we choose when we're talking about sequences. And it's again 4 plus 3 plus 3 plus a bunch of 3s. And so we have 4 plus 3, and how many 3s? Well, there's n 3s. Wait a minute. There's not n 3s. Remember, for 100, there weren't 100 3s. There were 99 3s. There was one fewer than 100. So here we have to have one fewer than n, or one less than n, which we write as n minus 1. So there we have it. That's our rule. We got it. That is called a direct rule because we can directly find the value of the term just knowing the term number by plugging in for n. So a sub n equals 4 plus 3 times n minus 1, and you could simplify that. I prefer not to because it's easier to explain where this rule came from if you're not simplifying. And of course we can use this rule to find anything. Let's find a sub 100, even though we already did, just to see if it matches up. So 4 plus 3 times n minus 1. Here, n was 100, so n minus 1 is 99. Well, that matches what we did over here. And then we can actually find our answer. So 4 plus 3 times 99. 3 times 99 is 297, plus 4 is 301. So a sub 100 is 301, and we could, if we wanted to, do that for any n. That's it. Pretty easy when you already know how. Keep practicing, and you'll get better and better at it. Goodbye.